Hi, my name is Michael from Beamex. Beamex, together with ISA, decided to put this video together to show you how you can calibrate a pressure transmitter. What we're going to do is have a documented calibrator, a pressure transmitter, sets of leads and a pressure generation, and we're going to show you how you can calibrate and trim the transmitter. But before I go there, I want to quickly mention this Ultimate Calibration book. This was my go-to handbook for all the calibration tips and procedures and things like that. Go and have a look. We're going to be using some of its content today when performing calibration. We right now have connected this differential pressure transmitter to a calibrator. We're going to be using this test leads to actually measure 4 to 20 from the pressure transmitter back to the calibrator. We're also going to be supplying loop power from a calibrator back to the transmitter. So that's one thing. So we've got that connected here. You can see also that the connection is made to the high leg of this differential pressure. Basically the high leg is going to go to a pressure source and also calibrator. So we're going to pressurize that to get the milliamps response. Also the low leg is open to atmosphere. So we've all got that set up right now. The only thing to mention here is if we go to calibrator and check our connections, we can test that very easily just by pressurizing the system and see if we're going to have the milliamps response, direct linear response from the transmitter. And it looks as if we've got a milliamps response directly to our applied pressure. So it looks like we're good to go. I'm also going to be using the accurate calibrator. In this instance, I'm using 30 psi module. The idea is that we try and aim to actually go 4 times more accurate than the unit on the test. It's not always possible, and this is our aim. This is what we're trying to do. So let's go to documented calibrator. The point of this is we're trying to establish how much this unit actually moved over time. It's been in service, it came back for recalibration right now. We need to check it against something, and we're checking that against a known standard, which is this calibrator. So that's the whole purpose. We could just check at random points, but of course this is not what we want to do. We want to do a proper document calibration. That's why we've got 5 calibration points. We're going to go up and down. We're going to go and pressurize 0 to 30 psi and then back down. So that's what we're going to do. But before I jump there, let me just quickly show you what else we set up here. The range is obviously 0 to 30 psi. It's 4 to 20 on the output. That's what we said. We also set up that this transmitter should be within 0.4% of span tolerance. Of course, that could be changed, but this is what we decided for this transmitter to be. Then also we've decided to give it additional conditions. These conditions are very practical. They very often use in a sense that you can go up to a certain level of error. For instance, in this instance, 0.2 and above. If we go between 0.2 and 0.4, the calibrator is going to let us know that we should adjust according to our procedure. So this is our procedure. We're also going to have that. Also, there is some information regarding before and after calibration notes. You can add your procedures, you can add your work instructions, you can add any messages you want your technicians to have a look at before they start calibration. So we're good to go. We press OK, we press OK again, and this is the before calibration note. Click OK. This is our screen. You can see right now we vented off the system. We read more or less 4 milliamps, and I think we're ready to go. Okay, we're ready to start our calibration. So we're going to document those 5 going up and 5 coming down. But before we do that, let me just quickly explain what we see on the screen. This is a direct feedback from our pressure. So if we're going to start pressurizing the system, you're going to see this changing. And also you're going to see the 4 to 20 changing as well, depending on how much pressure we're going to apply. Also, you can see the lines. These are the tolerance lines, and those lines, those conditions that we mentioned before. So if it's above that, it's going to say, please adjust, and it's going to give us information about that. Okay, we're ready to start. So the first calibration point is 0 and 4 milliamps. So don't forget, we're going to do 5 up and 5 down. Right now, it's going to ask us to go to 7.5. So let's do that now. So let's go to more or less 7.5. We don't have to be exactly precise, but what we have to do is obviously keep it stable, keep it as close as possible to that 7.5, and then we wait until the signal is stable, and then allowing us to save this calibration point and move on to the next one. So that's what we're going to do. Next one is 15, so let's do that. So we're trying to go to 15 or thereabout, and we expecting 12 milliamps. So we wait for this signal to be stable, and the documenting calibrator just accepted that one. So let's move on to another one. This is 22.5. We're going to pressurize it slightly more, and we're going to leave it there and wait for documenting calibrator to actually capture that calibration point. And the last point is 30. We just try to go there as well. Okay, and it looks as if that may actually trend it out. You can see that the dot turn red right now. It's actually outside of the tolerance lines, the blue lines. Okay, so we right now know that this calibration is going to be a failed calibration. What we have to do right now is obviously capture on the way down. So we have to go right now to 22.5. So we're going to do that now. When you going down is the probably more difficult than actually pumping, because you have to make sure that you don't go down too quickly, meaning you're not overshooting to that lower point. So if it's 22.5, just try to be there at 22.5. So be very careful when you actually opening your pressure source. So trying to get there to 15, thereabout, and we are at 15 at 12 milliamps. So just we wait there. You can see right now that coming down and going up, it's more or less the same line. So there is no hysteresis, which is good. That's a good characteristic of a transmitter, and we want to see that. But also, if you look at this graph, you would see that at 0, we had practically no error. The error looks as if is on the span, so we'd have to adjust that, to fix that and make sure we've got a pass result at the end. So it's fine. Let's capture the 7.5, and let's open the vent and go all the way to 0 to capture the last point. So we've done a 10-point calibration right now, 5 up and down. It's saved the calibration, so it's sort of accepted the last point, and you can see what information we've got provided here. You remember our tolerance was 0.4% of span. We achieved 0.437, which is 110% significant error. This is probably, arguably, the most important information here on this screen. It tells us how far out we are. So sometimes it could be 70, 80, 90%, 100% is at tolerance. So you need to make sure you're always under 100% to have it obviously pass. Information regarding other screens, like who did the calibration nodes. You can see the graph. You can have all that information there if you want. You can save information. You can save it as found, and you click as found, and you're ready to go right now to trim and adjust and make this transmitter pass, because at the moment is a failed transmitter. We have to fix that. Right now we need to go and actually adjust our transmitter. There are potentially two ways we can do it. We know that's a Hart transmitter. We know we can use Hart communicator to actually communicate with it and change those parameters that we want. But also some transmitters, not all of them, will have some sort of 0 and a span information here up top. Some companies allow you to do that, press the buttons and do the span and the 0 adjustment. However, what we're going to do today is we're going to use the communicator within our documenting calibrator to do that. And how we're going to do that is by starting a communication, because we know that this has got a built-in Hart communicator. So we're going to actually talk to that transmitter. And then when we do that, we try to go and find where we could and how we could trim both digital and analog sensor. So that's what we're going to do. We're going to go to Service Tools and Maintenance. Now, it's important to understand here that this menu is all to do with this particular type of transmitter. Different transmitters will have different menu. Just be aware of that. I know where to go. I know where to click here. But in your case, it could be different. So we have to do two things. One is analog calibration. All we have to do is click on that. And again, the guidance is going to be within your Hart transmitter. So it's going to be here, and it's saying to you, select option. We only have the digital to analog trim. You click OK. It's asking you to remove from automatic control. It's fine. It's asking you to connect a reference meter to this. We don't have to do that because our calibrator has already, or is already measuring 4 to 20, has already that built in inside. So we just click OK. It's actually telling us that it's going to set up the transmitter to 4 milliamps. You just click OK. You enter the meter value. It's 4 milliamps. You click OK again. It's asking you whether that's actually 4 milliamps. It is. So you're just basically following the instruction. So the questions that instruction is right now saying is that it's going to do 20 milliamps. You follow the instructions. It's setting the device to 20 milliamps. You click OK. Yes, it is more or less 20 milliamps. We're happy with that. So it's returning right now back to what it was. So it's fine. Analog calibration, analog trim is done. Let's right now go and do the digital trim. You remember from our results, we had a failed results at this span. So what we're going to do is do a upper trim. So we've got different methods. The only one that we're going to use for the purpose of this video is the upper trim. Again, it's going to be a set of instructions that we have to follow. It's all based from whatever manufacturers decided to tell us. So it gives us a warning. Yes, it tells us again about some information. It's asking us what sort of units do we want to have. We say PSI, it's fine. And it's asking us right now to apply high pressure. Now, this is 30 PSI. So we need to go there or thereabout on 30 PSI. So you can see that the input, so the sort of pressure and the 4 to 20 is changing. So try to get to, as close as possible to 30 again. So we can actually trim that. Right, okay. We're more or less there. It's probably fine. Okay, so you can see right now it's asking us to do that. Apply high pressure. We just did. Click OK. And it's actually asking us to copy this value into the field. So that's what we're doing. We're copying the value from one unit to what it asks us to do, and right now asks us to remove the pressure. So it looks as if that upper trim was successful. So all we have to do right now is go back to our calibration and start another calibration. So we've done as found, and that has failed. We right now need to do another calibration just to see if after trimming it's gone any better. So let's have a look. Now 7.5 is the next point. You can see that it's 0. It has already accepted the first point. Let's go to 7.5. Yeah, it's more or less there. So we wait for this signal to be stable, and it's asking us for 15. So, so let's have a look if we can get there. Right, we're around 15 right now, and you can see that the linear feedback is looking much better than on the first instance where it was just sort of trending out. It's asking us to go to 22.5, so we're going to do that now. Okay, again, more or less there. We try not to overshoot. We're trying to go and arrive at certain points as they are per our procedure. So we trying to go to 30 right now. So that's our last calibration point going up. And then, of course, don't forget we have to go back down as well. So that's what we're doing. We're at 30 and 20 milliamps. And right now we have to go down. So 22.5 is our next point going down. So that's what we're trying to do. Again, the same as for S found, we need to be rather careful going down. We want to make sure we don't drop too low. We would rather want to have a nice hysteresis, make sure they two aligned going up and down. So that's fine, that's looking good. So 15 now, so we're more or less at 15 now. And again, you can see that the linear feedback 4 to 20 from the transmitter is actually looking good. So it looks as if our trim has helped, and it looks as if we may actually pass this calibration after trimming, so that's good. Okay, and the last calibration point is 0, so just open to atmosphere and just wait for it to accept. So you can actually see that we are well within tolerance. It says here passed, do not adjust. You remember again those conditions that we set previously. You can actually see that they are in place now and they're working. Look at that again, 14.5% significant error, tiny error. This value may not be that much, but that value does. So just make sure you understand what that significant value is. So very low significance of that error. So that's good. Again, we can put notes, etc. We can see the graph and the numbers behind the graph. Right now, we can also save and combine those as left calibration, the calibration after adjusting, with the calibration that we did as found, which was the failed calibration. So the calibrator is actually suggesting that we should do that. So let's do that. That's allowing us to actually see on its certificate, see both as found and as left, two graphs, one failing, one passing. It's going to look nice. So right now we save this calibration, ready to hit back. There is another information about after calibration note, and if we hit X, we're ready to go and start another calibration should we want to do that. Let me show you right now how the certificate of that calibration that we just performed would look like. We just got our results from CMX calibration system. It basically looks like this. You've got the S found failed, as you remember we did. It sort of trended off, you can see here. And then we trimmed it, adjusted, and right now we can see the S left is pass. It's all displayed on a calibration certificate like this. That could be again printed off, put it somewhere in the document folders, or just left in the calibration management system. It's up to you, you've got those options. So there you have it. Calibration of differential pressure transmitter Hart using documented calibrator. Thank you so much for watching.